Hello and welcome. In this video we will be solving CSIR UGC NET 2019 June problem number 6. So the problem goes something like this. Assume that the earth revolves in a circular orbit around the sun, and suppose that the gravitational force G varies slowly as a function of time. In particular, it decreases to half its initial value in the course of 1 million years. Then, during this time, the radius of the Earth orbit will increase by the factor of 2, total energy of the Earth remains constant, orbital angular momentum of the Earth will increase, and radius of the Earth orbit remains the same. So how to start this kind of a problem? So what we have is, we have the sun at the center, and our planet Earth is moving in a circular orbit. So this orbit is circular. Okay, then what can be done? So let me just erase this so that we can start with the fresh page. Now we know that for central force, the angular momentum of the system is conserved. So basically total angular momentum is constant. Okay, and if you write the total energy, which is in the form of half mr square plus j square by 2 mr square minus gmm by r square. So you are familiar with the total energy in a central force field. Now in the problem it is said that G is not constant. So basically dE by dt is not equal to 0. Okay. Now for circular motion, what we can write is, if we do the derivative with respect to r, then it will be j square by mr cube is equal to gmm by r square, or basically we can write that r is proportional to 1 by g, right? And then what we can do is, we can write that r1 by r2 is equal to g2 by g1, right? Now it is said in the question that the value of G decreases to half after 1 million year. So let's say G2 is equal to G1 by 2. Then we can write that R2 is equal to 2 times R1. So the correct option is option A. The radius of the Earth orbit will increase by the factor of 2. Now let us understand the problem physically. So we have the sun at the center, and our planet Earth is moving in a circular orbit. Now imagine that the attractive force slowly decrease. Now what will happen? If the attractive force decrease, then definitely the radius of the orbit will increase, right? Let's say you have a very tight string, a very strong string, and you are spinning a stone. So it will spin, but if the string is like a spring, or it is a very thin string, then it will stretch and the radius will be higher. So definitely the radius will increase if the value of G decrease with time. So one takeaway is that the radius will increase. Now the radius will increase a factor of 2 or not, that you need to calculate. For solving MCQ problem, just remember that if the value of G decrease by 2, then the radius will increase by 2. So basically R is proportional to 1 by G. As you can see, we have done it here. Okay, so this is how you solve this kind of a problem. I hope that you understood how to solve this problem. If you like our video, do give a like, comment, and also subscribe to our channel. Turn on the notification so that you don't miss another upload. And I thank you all for watching.